Look at the animal kingdom. Every species holds a specific weapon. A cheetah can go from 0 to 70 miles per hour in 3 seconds. Gorillas possess roughly 10 times our raw strength. Eagles see with a precision our eyes could never match. Put an early human next to any large predator, and by every biological standard, we were built to be prey. We have no claws, no natural armor. Our night vision is poor, and our short-distance speed is unimpressive. For a very long time, humanity occupied the bottom of the food chain. When a lion brought down an antelope, our ancestors waited. We scavenged what was left, cracking open leftover bones with rocks just to eat the marrow. Early hominids did not dominate their environment. Fossil records carry the clear, undeniable tooth marks of large predators. We were something larger things ate, something that hid, and something that scattered. Then the fossil record reveals a sudden, quiet disruption. As humans spread across the continents, the largest animals that had ever walked the earth began disappearing. Not all at once, but region by region with terrible consistency. Woolly mammoths, giant ground sloths, cave lions, and rhinoceroses the size of small buildings. These species survived millions of years of severe predators, brutal ice ages, and catastrophic climate shifts. They survived all of that until they encountered us. How did a slow-moving creature with 0 natural biological weapons trigger the collapse of apex predators and rewrite the food chain of an entire planet? Picture a kudu antelope standing on an open plain in southern Africa. A human figure appears on the horizon. Every animal on Earth plays by a strict set of rules. The entire architecture of predator and prey is built around explosive bursts of energy. A lion wins fast or loses. A gazelle escapes fast or dies. Everything relies on a split-second sprint. The kudu sees the human and naturally runs. Within seconds, it puts enormous distance between itself and the slow, upright creature. The threat seems completely neutralized. The animal stops, finds shade, and rests. Then it looks back. The human is still there. Smaller now, but still moving forward. The kudu runs again, easily outpacing the threat, and rests again. But hours pass, the heat climbs, and the human continues advancing. Not sprinting, just walking with a dreadful, patient steadiness. This thermal diagram shows exactly why that pacing works. By standing upright on 2 legs, we dramatically reduce the surface area exposed to the direct sun. A 4-legged animal takes the full force of midday heat across its entire back, while a human catches only a fraction of that solar radiation from above. Combine that posture with millions of sweat glands, and you have an extremely efficient, continuous cooling system. While a running animal overheats and eventually must stop to avoid collapse, a sweating human can regulate body temperature almost indefinitely. We also have decoupled breathing. Most quadrupeds synchronize each breath with each step of their gallop. That rigid rhythm limits how long they can sustain a run. Humans, however, can breathe at whatever rate the body demands, completely independent of our stride. These 3 biological traits allow humans to hunt during the hottest hours of the day, exactly when the sun is most brutal and every other creature is biologically forced to seek shade. Humans are most formidable. This technique, known as persistence hunting, is still practiced by the San Bushmen in the Kalahari. They follow a single animal across dozens of miles, reading its tracks and anticipating its path, until the animal enters physical collapse through sheer, sustained presence. But physical endurance is only half the equation. Across broken terrain, a kudu will eventually cross a ridge or enter dense brush, dropping completely out of sight. A lion or a wolf that loses visual contact with its prey abandons the hunt. They rely entirely on immediate sensory data. When humans lose sight of a target, the pursuit shifts from the physical realm to the cognitive. A broken twig, a disturbed patch of dirt, or hours-old footprints provide enough data for us to continue. We read the environment to build a complex mental model. We factor in geography and animal behavioral patterns. Instead of reacting to where the animal is right now, we calculate exactly where it is going to be. The human body was merely the vehicle carrying an unparalleled cognitive process. We are the only creature whose primary hunting weapon was the mind's ability to run a continuous, accurate simulation of the future. The conclusion of a persistence hunt rarely involves a dramatic battle. It ends quietly, with the prey buckling and collapsing from physical and thermal exhaustion. Over thousands of generations, wild animals internalized a deep psychological fear of our upright silhouette. We represented an unnatural threat, a predator that simply refused to stop coming. We no longer track megafauna across sun-baked savannas. Yet the biological programming of the persistence hunter remains active in our brains. The same hardware that tracked a mammoth for 3 days now scans for modern problems. Dinosaurs walked this planet for 165 million years and left behind nothing but bones. A little over a century ago, we flew the first powered airplane, and only decades later, we placed footprints on the moon. No other species has ever accelerated its development at this rate. The ability to maintain a mental model of a goal across miles of silence is the bridge to modern discipline. When a researcher works on a single problem for a decade before the answer comes, they're utilizing the same evolutionary engine that once tracked prey beyond the horizon. We look at an impossible obstacle and work backward from the solution. Humans became dominant because they were the only species capable of continuing after everything else had already stopped. Our defining trait is the patient, almost absurd willingness to persist until the impossible gives way.